The least square method is commonly used to fit equations, lines, curves, functions, or models to data in various fields. Now let's delve into how it actually works. Weighted least square regression aims to minimize the sum of squared residuals when finding the best fitting curve for a set of data points in x and y. The residual is the difference between the y value in the data and the y value predicted by the curve for a given x. Weighted least square regression can provide an optimal solution when measurements have noise or small errors only. Weighted least square regression is sensitive to bad data, which can lead to biased regression results. This is because the weights assigned to the data points can heavily influence the regression outcome. If there are errors or outliers in the data, the weights assigned to those points can significantly impact the regression line. The scheme of minimizing the squared residuals of measurements used by weighted least square regression can indeed force the residuals of bad measurements to be small. This can result in a deformed fitting curve and make it difficult to detect the bad measurements. Weighted least square regression is prone to crashing without a solution when the bad measurements are severe or the number of bad measurements is large. SE Plus is a new regression approach developed by Smart Electric Grid, LLC, with support from the National Science Foundation SBIR program. It aims to select the minimum set of the most consistent measurements. The entire system is then solved by the selected minimum set of the most consistent measurements. This approach is different from weighted least square regression and other regression algorithms. Because of selecting the minimum set of the most consistent measurements, SE Plus is still able to obtain a solution even for a large number of big, bad measurements. In another word, SE Plus 100% guarantees a solution for a given set of measurements. SE Plus has the ability to automatically reject bad measurements and replace them with more consistent measurements. This ensures that the bad measurements do not impact the results of SE Plus. Furthermore, SE Plus is able to recover the true values of bad measurements by removing the error values from the bad measurements. WLS-based state estimators are more suitable for applications with small errors or noise in the measurements or system model and parameters. However, when dealing with severe or a large number of bad measurements, SE Plus is a better regression approach as it focuses on selecting the minimum set of the most consistent measurements. Weighted least square-based state estimators are not suitable for applications with a large number of bad measurements, such as power systems. SE Plus is indeed a better choice in these cases. Additionally, as a novel regression algorithm, SE Plus can help achieve a better application of AI-based technology.